Hello, this is Rani Ahmed with you, and this is lesson 5 in Objective-C and Macintosh operating system, programming on Macintosh operating system. And in this lesson we're going to talk about how to use the if-else statement, how to use the Boolean variable, okay, and what's all about this include file, and we will be talking about this type of instruction. Okay, it's some kind of an if-else statement. Now I've selected the quadratic equation, okay, solving the quadratic equation as a way to tell you how to use if statements. And here we go with the explanation of the quadratic equation if you don't know it. So the quadratic formula is this formula, which is a times x power 2, okay, which means like x times a plus b times x plus c equals 0. Okay, now what's the importance of this formula in real life? Everything in projectiles, anything that you throw, okay, goes on using this formula, okay, generally, okay. Anything that, like throwing stone, shooting a cannon, a rifle, okay, any kind of things like that's shot in the air, okay, all of them use this kind of formula, okay. But we want to know when this formula is 0, okay. That's why we put equals 0. So we want to solve for x here, okay, and find the value of x when when y is 0, when you are shooting just right away on your place, okay. Anyway, without making any leveling, this is without any height, okay. Anyways, all we want to say is that I want to solve this equation, okay, and find what values of x would make this combination 0, okay. Now there is here, as we see in the wiki, this is from the Wikipedia, it tells you that x will be, okay, minus b plus or minus the things under this square root, okay, b square minus 4ac, which is b times b minus 4 times a times c, okay. All of this is 2 times a, okay, and therefore x can be this and can be another one, which means that if you want to draw this on a graph, okay, you'll find that you might have like one and only one point, okay. That is when what we call the discriminant, which is this b square minus 4ac, which is under the radical, is 0, okay. So you get one and only one. Just calculate this and calculate this. You see that both of them is the same because you zerofied the b square minus 4ac, which we call the discriminant, okay. So when you get it as 0, you'll get one and only one x here, one solution here, I mean here, this violet one. And if this is a positive value, okay, you'll get 2 solutions, okay, this and this, okay. It does not mean this and this exactly, but you'll find that it will, that your parabola, this curve is called a parabola, we will see it crossing the x-axis twice, okay. This means you have 2 solutions. That's in real numbers. Now if this is negative, this means the discriminant. If it's negative, this means no solution in real life. Okay. However, there is something called complex numbers, and that deals with the negative root. Okay. Which the negative root is that, like, what's the number that you will multiply it by itself to give you that negative number. Okay. And this is impossible. Okay. Always two same signs will give you always a positive number. Okay, minus times a minus and a plus times a plus, both of them give you a plus. Okay, a positive. But you won't see like a positive and a negative. When they are multiplied, they will give you a positive. No way and never. Okay, that's why they created an imaginary number. They called it an I, and I square is -1. Okay, I times I is -1. But nobody knows what I would be. Okay, God knows only. So so let's go back and see how did I make use of the delta. Okay, because based on this delta, therefore there's a condition, therefore there's an if, therefore there's an else. Okay, this means that because of this delta value, okay, I can decide whether there is a solution or not in R. Okay, so back to our code. Okay, now first of all I must just skip this for now, just for keep it for later. Okay, and I have here, that's because I was making the Arabic version. So integer a -1 and b 2 and c is 1, which are the coefficients multiplying the x squared and x and and x power 0, which is, where is this one? Sorry, which is this one. Okay, here, sorry, the top here, I mean. So this is C, this is B, this is A. So back to our code. Okay, so when I calculate delta, and delta is not defined here, it's defined within the int main. So I'm saying just directly make delta as a float number, so it can take any kind of numbers. Okay, although you made it here integer. Okay, but it's up to you, no worries, because there's no problem with that. Anyway, so I'm saying if delta is less than 0, okay, so there's no, so I give a printf no solution R, and the meaning of this return being set here and written here is that you made your application quit the program, just write a way of writing this statement, okay, this sentence. So yes, so when I return from 0, it means that I'm quitting the current function. The current function is main, there's no other function, so I'm quitting the application. That's it. Quitting my program right away. Okay, next is I'm saying if it is not less than 0, which means that if which means else here. This is where I can go to the else part. So which is like when I say if here delta less than 0, the opposite is to use the sentence else, which closes over here. Okay, on this line here, this line. So so what's the otherwise? The otherwise is to say either when if delta is 0 or when delta is greater than 0. Okay, and when it's 0, okay, there's one and only one solution. There's one and only one intersection with the x-axis, okay, according to our graph, okay, on the Wikipedia. Okay, and yeah, so I don't want to see going back. So this is just one and only one crossing with x-axis. Okay, so back to the code. Now this is when delta is greater than 0. So again, this is two solutions. Here's the two solutions. Okay, and So depending on delta, I will be printing the printf here, okay, and because delta equals 0, this is double equal. You don't put one equal, okay, double equal. One equal is for assigning, okay, double equal is for comparison. So delta greater than 0, okay, and then delta greater than 0 and delta equals to 0 are like distinct unique situations, okay. So one of those printfs will be on the output, on the shell, and then I'm telling you that this is how you get the square root, okay. This is a float square root of delta. So what you do is root of delta, you define a variable. I named the variable root of delta, and I could have just wrote square root of f, square root f here. Here it means it takes a float, so square root f delta, and written it instead of writing root of delta here, okay. But it's better just for readability to put it in a separate variable, okay. And I made like %2.f just for sake of taking 2 decimals after the decimal point. And yes, I'm printing it, okay. So that's all about it. So if I want to run it, okay, let's save, and this is run, okay, and this is a solution R. There are 2 solutions, okay. Now here, if you want to see how it goes with one solution, so if I make it like it's like this, so it will be like this form of formula, which is x plus 1, all of it squared, okay, which means x plus 1, all of it times x plus 1, okay. This is equals to x plus 1 times x plus 1, and if you want to expand it, it will be like x power 2 plus 2x plus 1, okay. So this is all about the if statement, okay. Now you can make like a combination of greater than, less than or equal. I will show you what are they, less than or equal, things like this. So let's use our notes over here. So this is for equality. This is equal, okay. This is less than, and this is less than or equal, okay. Let's make it correct. Okay, and this is greater, and this is greater or equal, and this one alone is just for negation. So you can if you have, I'll tell you just a minute. So this is just for negation, so negation, which means not, okay, not something, okay. And we've got here the not equal, okay, because when you did 2 equals, it means this is exactly equal, this is not exactly equal, okay. So this is not equal, okay. But this does not mean that you can use the greater and the less, okay. This is something in logic. So you can do something like this. Okay. Like for example, a is greater than 1. Okay. Or this is the or. You type 2 pipes, which is just on the top of the key, having the backward slash. Okay, this backward slash, and also like c is less than or equal 3 maybe. Okay, you can also put all of this if you want. You can have as much as you want. Okay, and just like go and do something like this is double AND, which means the AND itself, like you're saying all of this is ANDed to like b not equals to 0. Okay, anything like this. Cool. So this is a condition. Cool. Now you can put that condition wherever you want in any kind of else if statements. Okay, and later there is also the while loops and things like that, so you can still use that. Now let's move to what's this bool all about. Now bool, we talked about, like, you know, there's the integer, the float, all of those, and the character and pointer and the struct. All those are types of variables, while there is another type of variable called bool, and it must be all in all caps, bool, like that. This is the boolean variable, which should hold something like here. Okay, something like this condition. This is how I'm defining something based on our data. Okay, current data, and here how I'm using the not value. Okay, because is positive is a boolean value, which means that it can hold only either a value named true or a value named false, which means that if this value matches, okay, the condition here, it will give the variable named is positive the value named true. Okay, otherwise it will give it false, of course. So that's why we will see how true and false will be flipped, okay, using this not. So now there's the not, okay, on the is positive. So this is a run, and see, now it's giving you a false. Now if I remove it and save it, it will give you a true. Okay, so depending on your situation, you can just go with the if statement. Okay, and as you've seen, there are as much as you want of a nesting of if statements. Okay, because you need to go into different paths in your logic. Okay, that's why changing directions as if you're like steering the car. Okay, this is a decision making. So every time you decide left or right, right or left. Okay, so on every left there is another right or left, and you're going to decide on. So this is how you can nest so many if statements. Okay, and this is how life is. Okay, so this is all about the bool variable. Okay, and what's all about which one? This one here, this kind of statement. Okay, now this is not effective here, but you can use, I mean, not effective here because I've put it in a comment here, but I mean, like, it is you can use this kind of assignment. This assignment, like for example, I'm here assigning an integer x. Okay, I don't have to run this anyway, but I'm defining an integer named x. Okay, and here is cool is some kind of a boolean variable or some kind of condition similar to this one. Okay, not exactly this one, but anyone similar to this, any combination of conditions. Okay, okay, but I have to remind you that you need, just for the bool variable, this is I forgot, for the bool variable you have to put this include. Without it, bool won't work. Okay, simply as is. Include obj c dot h. Okay, and it has to be between the acute angled brackets, you know, greater and smaller, you know. Anyway, so this type of assignment works in a way that if isCool matches to true, okay, like if you substitute every condition there and you calculate the conditions and then you've got a true value, then you will take the 1. Okay, x will take 1. X will take the side which is the true matching. If it does not match, it will take the -1, okay, which is the side to the next of the column. Okay, the after the column. Okay, so this is a kind of assignment which is similar to an if else, but I tell you, this is not really oftenly used. Okay, according to me, I don't know, but to me it's not that oftenly used. Okay, you see some programmers using it, but there's no harm to learning that. Okay, please, we're done now for this lesson, and please subscribe and your comments, and God bless. Bye bye.